Maybe while we're waiting for folks to come into the room, we can start off with some quick introductions. For those you who don't know me, my name is Dat. I'm a solutions architect here at Arise. I work very deeply with a lot of our customers and really the people building heavily at the ground level. Whether it's like LLM applications or kind of beyond, but recently, of course, in the past couple of years, it's been very heavy on the LLM side of things. But that's who I am. I architect and code with these folks, and really just like to get kind of down and dirty where are the problems and really architect and solution with those folks. But I'll let John do his intro.
Yeah. Yeah. And from my side, I'm John. I'm a developer advocate here at Arise. A lot of what I end up doing is focusing on our developers using the product, a lot of our community developers as well too, using our open source product. I'll work a lot with the teams that are using Phoenix and to help them get kind of set up using our product, do a lot of our kind of events and some of our technical content that we put out there. Really like to spend as much time as possible speaking with users of our product in the community who are experimenting with this stuff. Between Dat and myself, we have some of our takes on some of the different frameworks and tooling and things around agents. We're gonna go through a lot of that throughout this presentation here. But yeah, very excited. And I think we have a good critical mass of people. We're a couple minutes in, so I think we could probably kick off and get started here. Welcome everybody. We're really excited for this session. This is the first of a 6-week session that we're going to be doing here, focused all around agents over the next 6 weeks. So we actually have, I'll put it up here, we actually have a whole series of sessions that are going to be coming up over the next few weeks, really deep diving into different parts of agents within the AI ecosystem here. Our motivation behind a lot of this was that we were seeing a lot of cases where there was a lot of kind of marketing speak and sales speak coming into play with agents. They were being referred to in a lot of kind of these sort of magical ways. And we really wanted to take things back down to the hard tech behind agents, really focus on what is actually an agent, what is the tech behind it, how do you use them, how do you create something that's actually valuable and workable. We really wanted to have this whole deep dive basically over the next month and a half into how you can do all that. So we have today's session, we're going to be going through kind of basic, almost like our kind of intro session in a way, going through agent architectures, where things stand today with agents, kind of how we've gotten to where we are. We'll go into how agents are set up and some of the pieces that make up different agents. And then we'll talk a little bit about what we're seeing in the industry. We'll touch briefly on some frameworks, although we're going to save most of that for next time as well too. So we'll touch on that as well. And then we have a bunch of fun sessions coming up over the next few weeks for decomposing tasks, function calling, intent routing, all that fun stuff as we see going through there. With that, feel free to drop questions in the chat as we go or in the Q&A. We'll be checking that live as we go through. Definitely want to make this as interactive as you can make the Zoom webinar. So please don't be shy about dropping those in, and we'll try to kind of go through and answer those as we see them. But yeah. With that, we can jump into the first session of our series here.
Awesome. Thanks, John. And yeah, to reiterate what John said, yeah, my personal take is there's so much hype in the space, and they use these words that, I don't know, they don't really make sense. And we just want to bring it back down to like engineering rigor and like how to actually do this. And then, of course, John's right. We do love to keep these super conversational. So if you do have questions, we'd love to hear them in the chat. So thanks.
Awesome. So let's start with a little bit of like how we got to where we are now in terms of the agent ecosystem, if you will. So you cast your mind back about a year or so. The last kind of year of agent development was really dominated by these React agents. So these reason act agents that would kind of plan out different kind of steps that they would take, would follow through those steps, and then continually reflect and try to expand from there until they eventually converge to answer whatever kind of question they were posed or kind of get to an eventual response. When these were starting out, they had a lot of kind of lofty promises around being able to answer all kinds of different questions. They had these really broad solution spaces of what they could do and what they could get to, and they could handle all these different kinds of inputs and features because you're sort of having this general reasoning that can really work across a lot of different kinds of tasks. But in reality, they kind of amounted to mostly like Twitter demos, I think, in a lot of cases. You wouldn't really have, because the solution space is so broad, you end up with all these kinds of failures in different areas. They wouldn't really work reliably. especially with different kinds of questions. So they kind of collapsed under the weight of their sort of promised potential in a way. And so kind of come around to the beginning of the year, you see a lot of people kind of cooling the hype on React agents, and some people cooling the hype on agents in general. That's a whole other kind of topic there. But so some of the hype around React cooling down a lot. And we've started to see the rise of this sort of second generation of agents, or what we're referring to as the second generation of agents, which is much more kind of restricted down to specific kind of actions and things that these agents can do. We're kind of narrowing the solution space of what the agents can accomplish, kind of having different sorts of, or smaller set of kind of outputs that they can have, or paths that they can follow. So being much more defined about the execution flows that they'll go through and what kind of steps they'll follow. And generally have this ethos of the agents themselves are doing a little bit less, but they do that much better because you're able to be a little bit more structured and rigorous about what those things are. So like the really basic example is, instead of having an agent that can pull and scrape any website on the internet for information, you're now scraping only a few websites, but you know exactly how they're structured, and you can kind of build that into the agent so it's able to reliably gather the information that you need. So we're seeing this kind of transition here now to what we're calling the second generation of more defined agents and more kind of restricted solution spaces.
Yeah, and then I
Um,
guess one thing to add to that too, John, I think what we'll cover today is like objectively maybe what works and what doesn't, even though let's say these reactive agents don't work today. I think personally I'm like quite I want to be very bullish on them. I think they've got so far to run and go. So even though we might be pointing out like why maybe React agents don't work today, we are kind of bullish on them longer term. So
yeah, yeah, that's true. We'd love for they hold a lot of promise, and I think we just want to make sure they can like deliver on that promise and get to a point where they can be creating valuable things from there.
yep.
Um, yeah. So I promise not a lot of marketing speak, and so this is really not intended to be marketing speak, but I do think it's useful to kind of define what we mean by an agent in technical and sort of very specific terms here. So we want to be able to kind of have this definition that we can work off of before we start going through and showing some examples and deep diving into all the different components. But really boiling it down, what we mean by an agent or an LLM-based agent, to be specific here, is some sort of software system that's going to combine multiple different steps or processing steps that it goes through. Those will include some amount of calls to LLMs, either one or multiple, that are going to be used there. And then they'll also have some element of conditional logic or like decision-making capabilities to choose which kind of paths to follow down. And most will have some sort of working memory. So some kind of memory that will go through what that looks like and how that's used, but kind of a memory that you can access between different steps. So really, if we're boiling it down, it's kind of that idea of software systems with multiple processing steps, some conditional logic, and then some kind of working memory that they work off of to eventually get a response back to a user.
Yeah, and if you make parallels to the software engineering world, most of this makes sense. It's like
Mhm.
I need to call an API for some sort of input output from an LLM model, right? That's calling an LLM.
Mhm.
Logic makes sense, like control flow. How do I go from, this state to this state? And then memory, again, I think memory is also a bit of a hype word, but it's just carrying state in your application, which most of us are very familiar with. But
Yeah.
yeah, I agree. Definitely defining the definition, because you'll hear like autonomous agents or LM agents, or there's just so many words, new words being created, but it's nice to really ground them in software
Yeah.
engineering. And
Yeah, and we hear agentic thrown around as an adjective all the time now, and it's like everything can
yeah.
be described as agentic in some situation. So it's like if everything is, then nothing is to a way. But yeah, so helpful to define those kinds of things. So with that, I want to jump into a little bit of what makes up an agent. So we're going to go through the kind of different pieces and components and parts of typical agents that we see. So we're going to dive through what actually makes those up and kind of what each of those looks like. So kind of boiling it down to three here, we'll dive into each of these in a second, but typically with an agent, you're going to have some router or some kind of component of some sort that decides what step an agent's going to take or what kind of path to go down based on some sort of information. You're also going to have the individual skills and execution branches. So some kind of logic chain of actually doing the work or actually doing the task. So once the agent's selected a tool, how do you actually get the kind of result of that tool in some way? So like an SQL query skill that you might have to go pull from a database, or like a RAG retriever could be a skill. And we'll talk about those in a lot more detail in a little bit. And then, as we mentioned, the shared state or the shared memory that can be accessed across all of those different steps as the agent moves through. Um, and so, um, first off, the router piece of this is kind of the main piece. This is not something that's necessarily used in every agent. There are some that don't necessarily have a router, but typically what this is going to be made up of is some tool that can choose based on either a user input or the current state of the agent, what's the next path to go down, what's the next function to call or the next skill to invoke. And so this can take the form of an LLM, like an actual LLM call with function calling usually built into it or something along those lines. Can just be a more simple NLP kind of classifier as well. So you can have it actually scope down, use a smaller kind of just classifier based on what is the input. Let's decide the skill to go to from there. Or even at the very basic level, more like rules-based code here. So just like very specific, if this string is in the input, for example, let's go down this path. So you can have a couple different forms of what the router actually looks like there. I want to go through the router pieces, and I'm going to jump back to some of the questions that we have coming up in the chat as well too, because I see some great questions there that we're going to go into.
Sounds good.
Yeah. So yeah, just to keep going the router piece, and then we'll come back to those too. I mentioned there's a couple different forms the router can take of how you decide which step or which skill to kind of go to from there. The few different popular ones. One is using function calling with an LLM. So I think most folks are probably familiar, but for anyone who's not, the idea of function calling is you can basically provide a JSON description of your different functions that you want to equip the router with or equip the agent with as they're going through and executing. And they can choose whether or not to call one of those functions when they're presented with some sort of input. So you have this get current weather one. If you get a question from a user that's asking about the weather, then the LLM knows it can call this get current weather function. And so it'll respond back with that function with some kind of parameters pulled out of the user query to then have you go and handle that output from there. So that approach is using function calling here, which can be really useful for a lot of different kinds of approaches here. One piece is that it allows you to kind of, if you have a question that's going to trigger multiple different tools, you can handle those in a parallelized way. So you can actually speed up your program a little bit, which is nice, or speed up your agent. And then another piece is that it allows you to kind of continually loop through this LLM router step. And then eventually you'll get to a point where it decides not to call any kind of tools. And then it can actually just generate you an output based on all of the work you've done previously. So you can kind of combine your router and your final generation step, which is useful there as well. And then it also allows you to kind of take away all of the function kind of definition pieces from your router. Like you basically just have to tell your router, this is what I'm promising you. I have a function that will do this thing. And then you can handle that sort of separately from there. Another approach to this, as opposed to using function calling for your router, is to do more just LLM kind of intent classification. So just basically taking the user input and classifying it as a particular kind of like basically classifying it and then using that classification to say, okay, I should go call this skill. So you classify the user intent with the model, and then you go and say, okay, that user intent means I should go down to this particular skill or function or whatever it might be. This is useful because you're kind of reducing the complexity of what your LLM call would do, or maybe you're not even using your LLM, you're using like a more just classifier model itself. Because you're making it a little bit less complex of the job that it has to do, you're also reducing the kind of errors that you could see or the weird kind of responses that you might get. Like in the function calling approach, you might have an LLM decide that it's going to call like some wildly different function or even just generate a response itself. And so that can be really annoying sometimes. So it's useful to kind of scope down what your router is actually doing. So the intent classification can help with that side of things. And the last piece on routers here before we keep going is just kind of to level set. I think some folks, there's sort of two ways that routing gets used in the AI ecosystem right now. There's kind of agent routing, which we talked about, this idea of a router routing to different steps within an agent. But at the same time, this also gets used for this idea of model routing, where you're kind of like routing to specific different models based on the type of query that a user has. So if anyone's used like LLM or Martian or some of these tools that kind of almost serve as gateways to choose a model or something to route a particular user query to, that's a different kind of thing than what we're talking about with routing. So it's always just useful to separate that piece out there.
Yeah, one thing to add there too, John. Yeah, I just want to make sure people understand the semantics, router versus routing.
Mhm.
And a really, we are seeing this one more common in our customers as well, meaning like, and what's the reason why people think about model routing? Well, instead of my application directly calling an API, you're basically adding an interface between that call to an LLM and then whatever's on the other side of that interface. So there are, tools like Light LLM or Martian. Some people even hand rolled their own, basically like, let me call, hey, I'm gonna call this interface, and then I can get back whatever based off maybe cost. Some people use this like model routing to say, hey, what's the I guess the thinking behind it is like, can I just call the most, I guess, the cheapest model that performs the best? And sometimes that changes over time. And that's the real reason for the interface, right? So, not far from software engineering, really. It's like you don't want to couple tightly to stuff. And so the same exact idea here, with calling many APIs, you're just simply building like a software engineering interface so that if things change, you don't have to touch your application code. You just change the interface code and what kind of model is being called. But just want to call that out there and kind of parallels to software engineering.
Yeah. Awesome. So yeah, very basic agent that you can end up with here, just a router, and then that router choosing to call one of a few functions, and then those functions will return back to the router, and then it will continue to kind of decide whether to call functions until it is ready to break the loop and output to a user. So very simple kind of single layer router with functions, kind of one of your most basic types of agents here. Let me pause and go through some of the questions we have because we have quite a few of these here. All right. So first piece, what's the reason behind referring to it as an agent? I think it's just kind of back when we were talking about our definitions. It's a great question. I think because we kind of scope down the definition, it can seem like we're sort of just at some point it just becomes like, oh, it's just a piece of software or a program or something like that. I think it's still very useful to refer to it as an agent because there's certain kind of industry associations that you have with that. Like if you say what an agent is, even though there's a lot of things that you could argue about the definitions, it is a really easy shorthand to refer to kind of an AI system that can do multiple different things and can maybe interact with different outside tools or systems like that and kind of repeatedly loop through to get you some sort of answer. It's nice to have a shorthand for that sort of tool, even though we can kind of poke holes in the definition for it in different ways.
Yeah. And I think my take on why is it called an agent? I
Mhm.
think it was a word that kind of stuck. People didn't really know what to call it. And to be honest, you kind of want to build a little hype with the new technology. It's just an abstraction on across, and that abstraction definition can be very dependent on who you are and what you're talking about. But to be very honest, I think Swapna asked that, like, where did it come from? I think it was the thing that stuck,
Yeah.
in terms of like agentic behavior. I also think that like in the 70s and like maybe the first or second wave of AI, there was like a concept very similar to like having an AI kind of act on behalf of a human. And so it might have come from that too, but it's really the thing that stuck. And it's really, as John would said, part of the hype, part of the marketing. But when you're having a conversation with somebody, you should definitely say, hey, what's your definition of an agent? What do you mean by you have an agentic
Mhm.
application? Always good to get down to the nitty gritty core engineering of it all. But good, great
Yeah.
question.
Um, awesome. And then we have another one around like different design choices that we need to make before deciding a framework. So we're going to cover a lot of this kind of as we go through as well too. So we're going to go into some more detail about some of the design decisions there for like LangGraph versus some other approaches. We'll get a lot more into that in our session next week as well too, I would mention. So I'm going to pin that one until a little bit later in the presentation, if that's all right.
Awesome.
Yeah.
And then the next question after that was from Babak. And do agent frameworks or do agents work with multimodal foundation models too? To choose between different inputs, outputs, text, voice, picture? I think absolutely. Depending on what you're designing. I think agent is just like a catch-all word. You can design an agent to interpret pictures for you. You could design an agent to surf the web for you, and maybe the inputs and outputs, you can mix and match all those combinations. So I do think agents are encompassing of the multimodal world as well. So it doesn't just have to be input output text. But John would love to
Mhm.
know your thoughts.
Yeah, no, 100%. I think it can definitely encompass the multimodal side of things. Start to see more multimodal models and things like that over time. I think that'll be part of that as well. But But yeah, you can definitely have them encompass multimodal inputs, pieces within the flow. And then depending on the modality too, that could also be some way that you handle routing. So you could have like, if you get an image in, then maybe you're going down a different path with your agent than text, for example.
Yep.
Awesome. And then another one from Dipanshu, could an agent router include an LLM router? Since it's part of that intent router, attach the specific model to use based on the intent. So yeah, I think again, I think that's also something that you could do within an agent. So that's a great call out as well. It's sort of blurring the lines of what we are talking about of the routing versus the like router from before, but there's no reason that you couldn't have an agent that use different models depending on intent or depending on the input that it received from there.
Yeah. And just one design consideration behind that question too, Dipanshu, great question, is like, how do you know when to choose between like an LLM that routes for you, so an LLM router, or maybe like a classification? I think it really depends. We've seen a mix. If the decision is maybe really complex and it maybe like your router needs to decide maybe a combination or a set of tools to call to solve the problem, um, it's likely your LLM router would probably perform best there. But if you know, like, hey, I'm only really gonna go down these five particular paths, right? The reason why you might want to choose like an NLP classifier is really for latency. So you can imagine like an LLM call is on the bounds of like seconds in terms of latency, whereas um, an NLP classifier is on like the millisecond kind of magnitude, so maybe 2 orders faster. So the whole idea is like, what are you building for, and how do you optimize for that? So really great question, and the answer is like, it depends what you should put there based off of what you're trying to do. But um, and maybe the next question also is like, you have an agent, it does. Oh, maybe it's not a question; it's just
Yeah,
comments. So
yeah.
cool. Go ahead, John.
Awesome. Yeah, I'm gonna keep us moving forward here. So going to some of the next pieces. So kind of talk to you a little bit about what the router looks like. In terms of the kind of skills and execution branches, just to get everybody on the same page there. You'll see skills used as a term for this, execution branches as a term. But basically these are like the individual logic blocks or things that your agent can do that actually do a lot of the work for you. They are made up of kind of individual components, just as another kind of word to use to refer to these things. But those might be like LLM calls, they might be application code, they could be API calls, either internal APIs or external APIs that you're connecting to. But you might have a skill that is like, say, a RAG retrieval skill, for example. So you have an agent that can decide, okay, if I get a certain kind of question, maybe I should go perform RAG on some sort of data set that I have to get a response back. And so you have a skill that is kind of the full case or the full path of performing that RAG retrieval or RAG, I guess. And then within that, you have individual components for things like generating the embedding from the user's question, retrieving the documents from your vector database, and then generating a response for that, like after that full RAG pipeline. Each of those would be kind of a component within this broader skill of your RAG pipeline. So that's why we kind of refer to as skills. And what you'll see sometimes is that in like diagrams of agents, sometimes skills will get kind of collapsed into like one block of just, okay, this is just going to go off and handle all my like retrieval or all of my connection to an outside API and kind of response back from there. And sometimes it gets broken out. So if we update like our last graphical example here, you could have a case where we've got a router going to different kind of paths that are then made up of individual little components that perform kind of different logic steps. So just a useful kind of concept to have is that sometimes we'll refer to them as skills of a complete logic block. Sometimes they're referred to as like individual components, and you could show what each of those look like broken out. And then the last kind of piece of the three that we're talking about here is this idea of memory. So typically you'll have some sort of shared state that can be accessed by each of the different components within your agent or each of the different skills in your agent. And so this memory gets used to store everything from like retrieved context that you might maybe pull some context to pass back to your agent at some point. You might have kind of configuration variables that are set for that run of the particular agent. And then one thing that, depending on how you architect your agent, you could very likely have is some kind of like log of the previous steps the agent's gone through. So if you're doing like, say, a function calling agent with OpenAI, then typically what you'll end up doing there is you'll have like a log of the different messages essentially, and you'll append to that as you're going through and executing with different steps within your agent. Because then when you go back to your router, you're using that function calling approach, then oftentimes you want to include all of the messages that have previously happened so it can decide on the next thing to go to there. So kind of gets back to the architecture discussion of like what type of router do you want to use. Some are built on knowing kind of all the steps that have been completed so far. Some might just care about the most recent step and what's going to go to from there. But memory gets used to kind of pass this information around your agent. Um, there's a bit of an architectural decision here of, do you, like, if you just took a first pass at an agent, you might end up just passing sort of variables back and forth between the different functions as it completes and finishes its cycles. It generally is better to use a like sort of shared memory state, because it allows you to have kind of more asynchronous execution of or like parallel execution of tools or things like that. So typically it's useful to have some sort of like separate kind of memory almost object that you're interacting with. All right, awesome. So kind of just layering that into previous examples we looked at, this is really just illustrating that each of your kind of router and then your individual skills here in the pink are going to interact with the state. So you could have both your router and your different skills and components within them all interacting with that memory and that state as you go through and execute.
Yeah,
Uh,
and one thing to add too, John, for this one was like, if you think about why, like, okay, so why did we even mention state? Why is it important in these applications? When you're building like an experience, an LLM experience or an application for whatever, your customers, your end users, I think the thing that wins out or like where you're going to get a lot of adoption is like, does the experience feel magical? And one of those pieces is like continuity, right? Like if you've like imagine you had to use something like ChatGPT, but it just never remembered your conversation and you just have to like repeat everything you're saying. It just really it's a lot of friction. And so the reason why state is so important and why you should think about it in design is like, yeah, for that experience that is truly magical, a lot of times like not having to type in context that you've maybe already said, or maybe it's like context in like it was a previous session, doesn't have to be that session, it could just be. But I think with good LLM design, you want to be able to, if people can use your product and move fast, that's the target, right? And one of the fastest ways to people for people to slow down is like, oh, I have to give you all this context again, right? So I think when you think about the why behind why John's saying this, is like state is super important to these applications because you're designing that experience, and the best way to get to that is like these kind of design principles and like designing good AI, which is like, how do I move faster with this? How do I not get the user to work so hard to use my product? So just wanted to highlight that.
yeah, it's a great call out. So we have a couple questions coming in too as well, so I'd love to tackle those quickly as we go. So one is how should we look at agents versus software engineering design principles? Since to add reliability, we could actually use some code layer instead of the LLM for taking decision to the next step. But
Oh,
it's a great question here. I think this is kind of goes back to what some of the stuff we were talking about before. If you can use code to actually do some of the routing, that's like typically that's going to be more reliable. That's going to be a little bit faster in a lot of cases too. So it's kind of like if you can use code to do that particular routing, then it's almost always going to be better. I think what we find though is that depending on the agent that you're trying to build, you might not be able to actually define, like write code to define exactly that routing logic. You might have to rely on an LLM depending on the types of inputs that you're going to get from users. Maybe it's a really broad set of questions that you could be getting or inputs, or it's just sort of unbounded in that way. You might have to rely on the LLM side of things, but like software design principles using the code side of things is generally better, I would say, if you can do it, depending on use case.
yeah. Plus one to what John said. It like my hot take is like, don't get caught up in the hype. I would say
Yeah.
only use an LLM when you have to. It's like, uh, you meet folks and there's like, oh yeah, I'm using an LLM to like match this text to another text, and you're like, hey, regex is like a library that's like faster, cheaper, and works better. So definitely 100% to that. Only use like an LLM where you think it's actually kind of needed. And then the next question was, how is having shared memory state different from passing prompt parameters as it pertains to the LLM input? It's a really good question. So when we talk about state here, like imagine I built an e-commerce chatbot, right? And I'm like, hey, I want to buy uh, you know, black socks, right? And then maybe the chatbot pulls up some black socks that I could choose from. And like, and I say the next message I type in is like, no, 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 I want like nylon socks. And then the kind of application pulls up nylon socks. But what I really wanted was black nylon socks. And so when we're talking about state being passed, you can think of it as like this router kind of architecture as like being kind of like a state machine. So in like a session level, like where I can have multiple messages to a chatbot, you have like a conversation history. That's like the easiest way to describe it, but it gets more advanced than that. But the whole idea is it's not just passing, it's not just passing different prompt parameters as it pertains to the LLM input. It's actually passing in state from the application, right? So all the interactions you've had with this app in your application, should be storing that state to make that experience, like I said, much more seamless, right? It's like, okay, I asked for black socks, then nylon socks. What I actually wanted as a consumer was black nylon socks. Um, so hopefully that makes sense. And then maybe John, this one's for you.
Yeah.
How are we sharing the state between LLMs, but maybe it's
Yeah.
LLM calls?
Yeah. So, I mean, very functionally, you're going to pull whatever relevant state you have from this sort of state or memory, and then you're going to include that in either like the prompt or the set of messages that you're passing to that LLM. So, yes, you're kind of packaging it up and then including it in the call that gets made from that particular step. So, yeah, and I think one of the things to call out here is that we have state being interacted by each of the different kind of components as you go in each of the different pieces to really show that at any point you could be pulling from that kind of shared state and then gathering the info you need to then either pass into an LLM call or just pass into whatever other application code you might need that for at that particular step.
Yeah, and then the one other thing I would too like, there's a whole other presentation on like state management in
Mhm.
large language model applications, but just realize not all state is the same. So like I think
Yeah.
the simplest version of how people deal with state is like, let me just carry everything over, like from the conversation history to any API like returns that I have. Let me just put it in this big blob and then have the LLM parse through it. I think that's like the brute force way of dealing with state. But there gets to a point where that's not scalable. So if you have very big like outputs from like a call or an LLM call. You can't just like stuff it all in there. And even if you do, it gets like it's not the best way to do it. It's kind of like the dumb brute force way to do it. It's just like put everything in the history in this like state history.
Yeah.
Again, you could store it in memory. You could persist it if you wanted to, but that might get expensive. But generally people tend to store it in memory in a parameter and then they pass that and say, hey, here's the previous state. Here's, some customer asked this new question. Please answer the question based off the past state and this new question. Um, but just realize that not all state is created equal, and there's actually a hierarchy to state. And so you can start to design and develop more intelligent state systems. And depending on the application, right? Maybe you don't care about saving all of this, but these pieces of information, like personal information, is like super important. That way, when they come into the platform next, I can save off that personal information, but all of the return shopping information, for example, in an e-commerce use case, maybe I don't want to save that because it's not valuable. So again, the answer is it always depends, but I want you all thinking about like designing better systems in that way. And hopefully that makes sense.
The one thing I would throw in there to add to that is that depending on the LLM, if you are using like a function calling router, for example, some of them do kind of, they're just architected to take in the message history. So you might have to do that in some cases, but it's generally better if you can avoid it. Yeah.
Yeah. Yeah, I completely agree.
Um, cool. I love all the questions. This is great. Thank you guys. Keep these coming. So design wise, can each agent be seen as a parallel process or service thread that is generally listening for responses from various queries? I think that it's interesting that you kind of bring this up because it ties in with one of the frameworks that we're going to briefly touch on. They kind of adopt something that's a little bit similar to this. I think you could think of it in that way. I think it depends on if that kind of implies to me that you have like multiple agents that are running in parallel as threads and things like that. So you might end up with that. I think one thing I'll throw in there is that with all these applications, it's always easier to start synchronously and then add the asynchronous piece in later. Because if you're thinking of like one agent that might have parallel execution threads, that could get really complicated really quickly, and it might lead to more trouble than it's worth. The one place I would throw that in is that you could have a router that then gets back multiple kind of functions or tools that I might want to call, and you could execute those pieces in parallel and come back. But even that, like I can say that one of the things we did at Rise is we built a whole Copilot agent into our system a few weeks ago, and one of the decisions we made in that was to only have one tool be kind of invoked by the router on each iteration, because we were seeing so many issues with like overlapping calls and kind of messing up things with that asynchronous approach. So you can definitely think of them that way, but I would kind of caution against the like default to parallelization where possible.
Yeah, I would agree with that. Start simple. Trust me, complexity will easily grow in
Yeah.
your LLM application. So start simple so you can move fast and build where you have to, get complex where you have to. But if you can solve it with something simple, it's always a
Mhm.
very good engineering principle to follow by.
Yeah.
Next question is like, should we think of agent slash state machine as a DAG, or is it complicated like a graph? So when I think of DAG, directed acyclic graph or complicated like a graph, I think a DAG is a graph, but I think you think of like agents and state machines as maybe we can go to the next slide and
Yeah,
that'll
let's
really
we'll keep it going, I think, because I think we're going to answer that with some of the framework piece too. Um,
exactly.
awesome. Yeah. So okay, I'll keep going here. Yeah, just to kind of zoom out a little bit, we showed some very like simple diagrams, but as you start to get like a real world agent, so like a chatbot, for example, with some skills attached to it, this can grow in complexity pretty quickly. So you can have your entry point and like a user query, some sort of router basing the user, trying to determine the user intent, launching into one of your 5 different kind of execution branches here with multiple different components that might they themselves call an LLM or something like that as you go through. And then what this is not actually showing is that once you get to the end of that, you might route back to your router and then try to kind of continue from there. So these things definitely can like balloon in complexity as you start to add functionality. So that's something I think to keep in mind.
Yeah,
Uh,
yeah. I think to answer one of the questions in here, like this view is more like how does like the application flow feel like? Doesn't necessarily mean this is how the backend runs. So I think when you think about the backend here, it's very much a state machine, like for like a chatbot that can has skills and while this does look like a DAG, some of these components could be cyclic, right? Some of these
mhm,
components could be looping, some of these
yeah.
components. So it's more of an example of like what is like the flow feel like in the application, but it's not exactly the implementation of the backend. So if you're familiar
Mhm,
with like maybe some design choices for code, some people go object oriented, but state machine is actually a very good way to describe this. Is like, you come into the entry point, you have an intent, the product, the application does something. Maybe it's not exactly what you wanted, and so you want to be able to come back there and say, hey, actually, I'm searching for this, or hey, I found the thing that I wanted, but maybe I want to compare this to another product. And so
mhm.
the state just continually gets updated and updated until you have like the user experience that you want. So just know that this view is more of like how does the application flow versus, you might have the back end might look completely different, which might be closer to a state machine.
It's a great call. Awesome. So those are a couple examples of like the components and the pieces of an agent and some of the basic flows. I want to touch on frameworks sort of briefly. Again, for anyone who missed it, our session next week is going to be like deep diving into a few popular frameworks and actually showing the same agent built in each of those different frameworks and kind of showing more of a comparison. But I do want to just sort of touch on each of these as we go through here to kind of make sure that folks are aware because it's also helpful to understand some frameworks that are out there. So when you think of agent definition kind of frameworks or agent orchestration frameworks here, LangGraph is one that's very popular. It's sort of the oldest, which is funny because it's like a year and a half old, but it's like the oldest in the space, I think, or one of the oldest ones. But generally, LangGraph, the kind of ethos behind it was that it was actually designed as a response to DAGs in a way. So if you go look and read the kind of initial blog for the announcement of LangGraph, they're talking about how most things that they had been developed at that point were these pipelines or chains, very linear. They were not cyclic. You couldn't like loop back on them, or it was very hard to kind of code that logic in. So LangGraph was added as a way to help manage more like cyclic and looping applications that might go through, still using a graph-based architecture and like representation in a way. But they add in the capability for looping and kind of add in some other pieces there to ideally make it easier to build agents. That's kind of the goal here. So LangGraph has a similar sort of setup of different things where they'll have nodes, which are kind of individual logic blocks in a way of different things that might be happening. So in this example on the right, you have like your classify input node. That's kind of like the router that we had before initially. One thing to call out with LangGraph is it doesn't really have the same kind of concept of a router necessarily. it sort of moves that logic into somewhere else that we'll see in a second, but uses these nodes that you can access in different places that have different kind of logic blocks they complete. So those are kind of similar to our components from before. And then you move between the nodes across different edges. And so you actually define those edges within LangGraph. And there's a specific type of edge that you can define within LangGraph that's a conditional edge, which if you look on the diagram on the right, is greeting is kind of an example of what that might be, where say you have an input that comes in, you run some logic to classify the input as either a greeting or like a RAG question in this sort of contrived example on the right. And then you feed the output of that into is greeting, which is a conditional edge. And then that decides which node do you go to there from there. So you're kind of moving the routing logic almost into these conditional edges in a way. Some of it you could potentially handle within the nodes, but you kind of have to think in terms of nodes and edges, and you can always loop back onto a node and kind of have these loops within the architecture. But if you actually go into code for LangGraph, you're like literally defining things as a node or an edge as you go through there and kind of connecting things up in that way. So that's one approach. And then we go a little bit more recent. Earlier this summer, saw Llama Index Workflows, which is sort of Llama Index's version of LangGraph in a way, designed to solve a similar problem of making it easier to define these cyclic agents where you're coming back to certain steps earlier in the program a little bit more easily, among other kind of motivations there. And they have their own kind of concepts that they use. So instead of nodes, they have steps, and somewhat instead of edges, they have events. And so for Llama Index, what they go for with this workflows approach is more of this idea of kind of individual steps that complete logic, and then when they're done, they broadcast events, and you define what those events are, and you can have a step broadcast an event, and then a future step might receive that event and sort of subscribes to receive that event whenever it's broadcast, and then we'll go through and handle the whatever logic is based on that. So you can still draw it in a diagram in this way, but you'll see kind of the arrows are those events. So what happens here is you've got like your answer query step that's going to broadcast either a query failed or a query succeeded event. And then you've got an improve query step that's subscribed to receive this query failed event. And then when it completes its logic, it'll broadcast a retry query event. So you can represent it as a chart here, but it's more like you're broadcasting and receiving events as you move through. So two approaches to kind of help you create agents or add structure to agents that some folks are using in different capabilities. There are a ton more. There's a bunch of tools like Crew AI and AutoGen from Microsoft and Swarms and all of these different things that are all designed like frameworks to help you either create singular or multiple kind of collections of agents working together. Some of these even use existing frameworks as well too under the hood. So there's a lot of different frameworks out there. And again, we'll touch a little more later on, but we'll share some in a bit here about kind of our opinion on using frameworks versus not as well. But yeah, so just know that there's a bunch more frameworks that you can touch, and we'll get into that a little bit later on too. And with that, Dat, I'll pass it over to you to kind of go through the final considerations and takeaways here.
Yeah, and then we'll go through questions after that. But I just want to give, take everything I say with a grain of salt. I really take things of like with all the customers I've seen and built with, and then all the frameworks that I've played with. These are the things that we kind of wanted to kind of leave you with. So if we go over to the next slide, I guess the first question is like, do you even need an agent? So maybe some questions you'd ask yourself is like, does your application follow an iterative flow based off incoming data? And so, what's kind of meant by that is like, yeah, like I think this first requirements question makes a lot of sense. But if something is like iterative and it requires, it feels like a state machine, or it feels like, hey, more complex things are building on top of each other. It's a good possibility that you might need an agent for this to abstract away, or maybe to like, so you don't have to explicitly code this up because you can't determine all paths, right? With if you're trying to build these magical experiences and you want your application to be able to handle, not the world, but a good amount of like what it's intended to do, then yeah, it might be a good idea for kind of this. John, any takes on number one yourself?
Yeah, I think for this one, it's really, if you have, as you mentioned, the state machine is probably the thing to think of here. If you've got an application that's going to sort of iterate through multiple different steps, and you have this kind of iterative flow where you're having new data come in, and then you're going to like repeat some sort of action or take like kind of redecide which flow to follow from there based on that incoming data, that's an indication that you might have a case for an agent in this flow.
Yeah. And then that kind of goes along with number two is like, does your path need to change? And like, does it need to adapt based off of what's been previously done, aka like state? So even though I asked for black socks, maybe when I ask for nylon socks, I want actually black nylon socks. And so this is kind of where the magic is. But yeah, if you need things to be a little bit more flexible, might be a good call. And then number three is there a state of actions that it can be taken. Again, that kind of falls into the space, but really for this slide, if you can answer these questions, then it's very likely you need it. If it's something that can be done like explicitly, you probably don't need an LLM, and you might be falling into the hype. I think of like using an LLM API and the software engineering around it as a tool, and just make sure you're using the right tool for the right problem.
Yeah. Yeah, and I think number three especially is very useful for this because it's kind of the same question of like, do you need an LLM in some ways of if you can define all the outputs that all the inputs and outputs of your program, then theoretically you could like build like code all of the paths there. And so it is once you either that gets untenable or you have these sort of undefined outputs or undefined inputs that you either have to process or create, that's where it can be more useful to kind of use the LLM piece. And then that's where you get into this consideration of, okay, I need that. Do I actually need an agent? So that's where the other two questions can help out there too.
Yeah, and it's like a trade-off between like, I don't know, I think it's like flexibility
Mhm.
versus like reliability in a sense.
Yeah.
Like code is deterministic and it's very good at, it's very good at being deterministic and executing consistently. By definition, LLMs are designed to be non-deterministic, and that's what gives it the flexibility, but also why it can be tricky building around them. Awesome. And the next one is like, do you need a framework? There are pros and cons here. I have a hot take at the end of this, but some of the pros are, I think, uh, they kind of force you into their paradigm. So we looked at laying graph, and then llama index workflows, and so they do force you into a structure, which is kind of good because if you actually kind of subscribe to that paradigm or abstraction, because all these frameworks are really is an abstraction on software engineering. That's all it is, and it's like they all have different ways of doing it or thinking about it. Some are more mature, some are less mature, but the whole idea is that they're all just abstractions. And it's not until you get deep into that framework and you understand the abstractions and the choices that they made that it starts to make sense. So I think one of the pros is one, it's just if the framework makes sense in your head, it's like really nice because you don't have to think about it. And someone, a team of whatever, 5 developers or more have already kind of thought that out for you. The other thing is just like the abstractions, of course, make things easier to understand. Um, and lastly, they're continually improving. And I would actually add a fourth point here. They help you get started very quickly, right? So like if you're a first timer and you're like maybe not that great with code or you're kind of new to this world, I think a framework is a really great place to start. But John, I would love to hear your pros for frameworks.
Yeah, I mean, I think that last one you're right. That's the one we should add on here as well too, because that really is the nice thing is like if you're going to use one of the frameworks, there's not just like sort of rails to help you get started, but there's also a ton of examples and notebooks and tutorials and things that you can follow. So there's a good amount of people building with the frameworks as well, especially for those kinds of like getting off the ground use cases. So I think that it's a great place to start if you want to kind of have a good like thing to follow on, and then you can always sort of decompose it later and pull the framework off once you see that. So I think from the pros side, I think that's sort of the nicest thing is just the support that exists around them and the ease at which you have getting started too.
Awesome. And then maybe on the con side, this one will be kind of interesting. I think in the current state that we're at, there's a fair amount of cons. I think frameworks are very good for getting you started. And as I'm bullish on them as they mature up. But sometimes the paradigm doesn't fit what you're thinking. And sometimes when you're building an LLM application, you're given a constraint that falls outside of the paradigm of that framework. And so now you've just invested a bunch of kind of technical investment and learning and into a framework that can't do what you need it to do. And then now you're kind of forced to somehow work around it. And it can be very tough and sometimes feel like technical debt. So that's kind of one of the cons that I see there. And then, abstractions tend to make things way easier, which is good. But sometimes like those abstractions they're too abstracted away from the thing that you want. So
Yeah.
and yeah, go ahead, John. You can talk on these
Yeah,
too.
I think it's that um they tend to get in the way is really the big takeaway for that second point. Is like if you're trying to set up your code and you're having to rely on these abstractions, they can oftentimes get in the way there. And I think just speaking very like practically with a few of these as well, they kind of come along with the general, like if you're using LangGraph, you're going to use LangChain. If you're using workflows, you're going to use Llama Index. Like they kind of come along with the pieces and end up relying on a lot of their own primitives and kind of types essentially. So I think just like the experience of going through and developing with these things, if you're trying to add in a framework, you kind of need to add in and need to abide by the types used by them. And that's everything from like you have a specific object for a chat message, for example, that you're going to send through to a model, which is useful. But it does mean that you have to kind of subscribe to that type. So it's almost one of those things where if you're really used to building with a LangChain or a Llama Index or other frameworks like that, then it can be really easy to step into these LangGraph or workflows because you're familiar with those ecosystems and they use the same types and they use the same kind of logic or kind of primitives within the code. So I think those can make it a lot easier if you're getting started. If you try to do specific things where you might need to like use a different kind of type or message or whatever it might be, you have to do a little bit more like kind of digging through to figure out, okay, exactly what is this type and what parameters does it need here and how am I going to kind of create the right object that's going to be accepted by the different steps within that flow.
Yeah, and people come on these calls for the hot takes, so I'm gonna give the people what they want. Look, as like I would not a veteran, but I would say I'm pretty advanced in this world, and
I think you're a veteran. So, yeah.
maybe I could just paint a little picture of what I see. It's like I think if you're first getting in this space, the frameworks are a great place to start. It's a great place to learn. Now, if I'm building something for production or a company, what I notice is as people level up, they get better and better building these things. They start to outgrow some of the frameworks. Don't get me wrong. If you find a framework that makes sense with your paradigm and it hits all of the criteria that you could ever want, you should do that, right? It would be madness to reinvent the wheel when the wheel's already there. But I will tell you is like the frameworks are also growing and they don't always hit the mark. And so what I noticed really working well in production is like my hot take is I think the framework you should be working in is the coding language that you're using. I'm a big fan of like you can abstract where you can, like if there's like lower level components, like if you don't want to build your own model LLM model routing, maybe you use light LLM, right? But the whole point is like you don't need to abstract so highly and lock yourself into something that might not scale into the future. And it's definitely a common path that I've seen a lot of people take. But as you become more advanced and more capable, what you'll start to notice is that the framework you're actually working in is software engineering. And the base, like the best framework you could work in is the coding language itself. But again, if you do find a framework that fits your paradigm perfectly and can grow with you, choose it. But coming from someone who's worked a lot in this space, I think I just really enjoy, you can just customize so much better yourself for the thing that you want. And if the thing that you want is very bespoke, don't get me wrong, if you're building like a nice Twitter demo, I don't know if I would hand roll that myself, but that's my take is your best framework today in 2024 is your coding language.
Yeah. Awesome. I think we've covered a good amount of these, and I know we only have a couple of minutes, so I might say we go to questions if that's cool with you, Dad.
Yeah,
I
let's
don't know
do
if there's
it.
anything you want to highlight from here just quickly, but I think
Yeah.
otherwise, yeah, okay, cool. So yeah, I think we saw some questions that were coming through. Let me make sure I get back up to the right spot. So, okay, so we had one on the checkout box on the chat to purchase app flow. It's carrying a lot of weight. Do you have any suggestions for how to handle things like authorizations to conduct transactions and providing payment methods for agentic AI systems? That's a great question. So, like, how do you basically provide AI agentic systems or agents? Let's just not use the word agentic there because that's we said that at the beginning. AI agents access to like more secure things within your system for sure. Um,
You,
I could, yeah,
go
I can
for it,
briefly
John.
touch on this. Dad, you're probably gonna have a better answer than me, but one thing I'll call out here is we recently had a jailbreak attempt on that Copilot agent that I mentioned we built, and one of the things that was really helpful there was that it was actually separated from like sort of logically separated out from any other systems that it could interact with. So I think from a kind of security perspective, having that logical separation is really helpful. you can also leverage some of the same authentication that you do for a user or an agent as well. So we've had some cases where folks have kind of used the same authentication kind of token process essentially for users as they would provide that agent with a token kind of within the shared state that the LLM wouldn't access itself, but then you can use that token as an authentication method for some of those systems. So we've seen both those things. Dad, I would love to hear your take on this too, because I think you've probably seen more of this.
Yeah, so
Yeah.
suggestions for how to handle things like auth to conduct transaction limits, things like that. Yeah, I just don't think I think you just come back to software engineering. So in the same way we do that with a standard agentic framework, you just don't let the LLM touch any of that stuff. Is like my take. I think a lot of these problems are already solved, but don't don't involve the LLM if that makes sense. So I want to make sure I'm reading the question right. Do you have any suggestions for how to handle things like authorization to conduct transactions and providing payments for agentic systems? Uh, yeah, so like if you can avoid using a non-deterministic component in that aspect or something that could be, I don't know, jailbroken or things that require authorization. Yeah, I think as John said, there are mechanisms for that today that like exist and that system is pretty straightforward. But yeah, I would definitely do some um, extensive testing and just yeah, heavily gating or guarding off those aspects. Just
Yeah.
assume a bad actor where you can, if that makes sense.
Yeah. And I think I'm not sure. I think we were probably answering the question there. I guess the only other way I could take that question would be how do you prevent the agent from taking action the user wouldn't want them to take automatically, or maybe? So maybe like how do you get the users off like sort of consent to complete a transaction or something like that? In which case, I think you just present it back to the user. You want to make sure that you can always say, hey, have the
Right.
agent say, hey, I want to do this thing next. Is that okay? And then kind of
Yeah.
go from there. But
The
I'm not
are
sure.
you sure? Yeah, like are
Are
you
you
sure?
sure? Yeah,
Yeah.
yeah,
No, it's a good
yeah.
call.
Yeah. But yeah, going through the rest of these. In our experience, these new enough to be included in coding tools like Cursor and Maven. I actually can directly speak to this because I've been working with both these frameworks for the past few days. LangGraph is good in Cursor. I've used it in there and it will work pretty well. Workflows, somewhat, yeah. I was able to. I basically was able to take an OpenAI pure OpenAI assistant, go through it, and basically say, hey, Cursor, convert this into using workflows, and it sort of worked. I had to go in and do some actual kind of tweaking after the fact, but they're new enough and they are included in some of those code helpers in the knowledge base that they have, despite being so new. Yeah.
Awesome.
Awesome. And then using a chain of LM calls when following considered an agent. Oh, I see also, Josh, thank you for jumping in with a couple of these answers here too. I think I would agree that a predetermined chain is not really like an agent by nature. It gets into the definitional question a little bit. Like you could argue that if you have like a router with one skill that just doesn't have any looping, like it's not really an agent at that point, but it's again sort of the fuzziness of the definition a little bit, I would say. Uh, and then we are going to show the recording. We'll definitely make sure I can share it out afterwards. Um, Different agent-based frameworks available. So I think we mentioned a few of them around index workflows, LangGraph, True AI is another one, some other auto gens in there too. And again, the next session we have next week is going to focus kind of purely on frameworks as well. And let's see, intent classification when the routed skill does not require parameters or parameter static. You would still end up wanting to do intent classification in that case, because you have to basically decide which function to call or which tool to call. So even if there's no parameters or the parameters are static, then you typically use the intent classification there to decide what function to go to or what next step to go to. And then there's sort of a separate piece of that of extracting the right parameters and setting the right parameters. So even if the parameters are static, you would typically still have that intent classification kind of piece of it too as well. And then we've got one for when we say tool or function, would function refer to a code function while a tool is not necessarily something? Oh, it's a great question. To be
Yeah.
honest, we kind of used them interchangeably throughout this presentation, and that's somewhat indicative of what is the case in the industry. Like if you look on, like OpenAI is a great example. They have both functions and tools within their system. functions are a type of tool, but allegedly there will be other types of tools. There are not yet other types of tools to my knowledge. So it's like the only type of tool is a function. So it gets very confusing with some of the definitions there. We mean sort of the same thing between tool and function. I think yeah, either one could be going to some sort of code function or some sort of other kind of piece of your program that completes something from there. So usually they get used somewhat interchangeably. I don't think we have a technical definition for the difference that's accepted by everyone in the industry.
No, it's a good call out. I think
Yeah.
tool is also one of those hype words. It's like,
Yeah.
it's if you like, what's the software engineering principle of all this? It's like, yeah, you're calling a code function that, or an API, or think input output. I'm
Mhm.
sending a payload to do this. I get something back. That might be a tool call, could be API call. So yeah, tool is also one of those marketing words. It just sounds fancier than it is, but coming back down to earth, yeah, you can think of it as like some sort of code that does something useful that is performed as a component in uh, this kind of code or application running. But really good call out, Vignesh. It is a bit hyped, and we should probably
Yeah.
not use the word tool.
Yeah, that's a good call out. Awesome. I think that covered all the questions that we see in the chat there. Awesome. Cool.
Yeah, before we hop, just one quick
Yeah.
thing. If you look at the box on the right, if you guys could just give our open source tool, Arise Phoenix, a star on GitHub, we'd really appreciate it. It pays for these webinars, it pays for our pizza to eat, so we really appreciate it. And thank you so much for joining. I know I really enjoyed this, and thank you so much for the great questions. And we're really excited for the next series, which will go even deeper on not only the frameworks, but a lot deeper, and we're going to definitely keep it less hyped and more engineering centric. But thank you all.
Thank you, everybody. And we'll hopefully see you soon on another event. Take care.